In regard to the flag, I sat there in that meeting and suggested that, if we had a freestanding flag, it'd be much more appropriate than just depending on the moon flag the American flag painted on the lunar lander. So I got an action item to come back with a projected, scheme. So I went back to the office and I remembered how nicely telescoping tubes work and so on. So I got some telescoping tubes out of the shops and we made up a prototype. And then I got a directive to show it to Neil Armstrong and see if he would approve of what we had. So he came over to the Tech Service Division. We put our flag together on its little prototype. And he said, "That's perfect, let's go with that." So then the details came out. We had to be able to have somewhere to put it that would be easy to have access to. So we went out once again to this mock-up that we had there. And Dave and I looked it over and we thought, well, if they come down the descent ladder and walk around about 3 steps to the side, if we hang it underneath the armrest of the ladder, that'd be a nice handy place. So we did. We designed a way to fasten it on the underside of the descent ladder armrest. And we added things called pip pins. They're real quick releasing. You just squeeze them, and when you pull them out, a ball intercept that releases itself, and you can just take the thing right off. So then I had the design. We had to put a hinge in the top of it and tubing. Got to thinking about it's going to just hang limply, and it's got to fit in a 3-foot long package. We can't have a 10-foot pole sticking out there. So we made a telescoping piece for it. And this is where the story gets even funnier or more interesting. We put linkages. We used the concept of a telescoping tube that's inside of a drape in a window, just a sliding effect. And we added these tubes of a length that would fit in a maximum 3-foot length, so that that was okay. And the idea was to hinge it up on a 90-degree hinge and have a stop so it would catch and it would just stand horizontal, the one tubular limb. But in the meantime, since we had to hold it, we sewed a seam in the hem in the top of the flag. And by the way, this was a GSA warehouse issued flag that costs about $5, as I recall. They're nylon, and I got thinking that nylon would stand 200 degrees plus or minus, and they ran tests to prove it did. So with that in mind, we were able to slide the tubular piece hidden within the flag and stretch it out. And if you pulled it all the way out, you'll see if you look at the 11, and 13, 14, 15, 16, 17 different moon landing pictures, they all have flags out. They moved them in different ways, different amounts. But we fit the vertical pole. It had to be a 10-foot tall pole to do its job. So it had sections that fit inside of one another. And the lowest section had to be something one could drive into the soil without damaging the joint you're hammering on. So we put a hardened insert out of hardened steel. This is tubular aluminum, very thin, lightweight aluminum. So we built it with a hardened piece for hammering. Then we told the astronauts you'd take the hammer out of your geological toolkit and pound this thing down, and we put 2 different red lines on it, one at I think 12 inches and one at 18, as I recall, that were to tell them, if you hit it this far, it'll be okay, but don't exceed this distance because it'll be sitting too low. I'm so proud of that, because that flag is on each of the 6 moon landing sites. I gave 2 suggestions, and that were the only 2 that were taken. The flag and the plaque.